Hello, my name's Devon Barnes. I'm a fourth year PhD student at Utrecht University, and I've been working on developing the kidney AOPs as part of Work Package 8 for the ONTOX. My poster, aptly titled, is concerning the development of an in vitro battery to help predict nephrotoxicity by elucidating some of the early onset mechanisms that we see in kidney toxicity. The purpose of my poster this year was to really capture the sort of iterative workflow that I've been developing over the past few years, nominally using in vitro battery models, basically just encapsulating our conditionally immortalized proximal tubule cell line, and then using these to basically help predict and simulate these kidney tubular responses by integrating various methodologies. The first study that I performed initially was for the data curation and gathering, where we looked at developing a network of AOPs specifically related to nephrotoxicity. By collating this data of over 13 AOPs on the AOP wiki, we were able to create this lovely looking spider diagram over here, but not just that, but also perform some network analytics to basically identify the distribution and the connectivity of different key events and key event relationships to be able to really pinpoint the key events that we need to identify for the common nephrotoxic events. Essentially, this enabled us to isolate cytotoxicity, oxidative stress, mitochondrial dysfunction, and tubular necrosis as the four main key events to integrate into our iterative workflow. The in vitro setup was quite simple. We just basically utilized the simplistic 2D monolayers with the growing of the SIPTEX and analyzing them using fluorescent and absorbance and analytical metrics. Initially, we utilized just simple Alama Blue, Presto Blue stainings to basically identify the cell viability over 3 different time points, 24, 48, and 72 hours. And once we got these nominal concentrations based on our CC10, cytotoxic concentration 10% values, we were able to then look into other more advanced mechanisms of toxicity, i.e. looking at tubular necrosis, mitochondrial dysfunction, and oxidative stress using various assays. One of the most interesting metrics to come out of the report actually was when we looked to really encapsulate some of the SAB-related feedback we got from the Milan annual meeting, where we actually then tried to target, we used an assay measuring N-acetyl glucosaminidase, which is one of the FDA and NIPH approved urinary biomarkers, and really got some interesting data. Even more so, the data that I show here was just looking at various metrics within this, but the full reporting will actually go into a lot more detail and really publicize exactly how much better these analytical metrics were over more traditional biomarker studies. Last but not least, we basically wanted to then utilize this approach to be able to identify more key events that we could begin looking at expanding our network, namely just using the lowest concentration of our 3 platinum compounds to identify over 1,200 differentially expressed genes that we could then run through a simulation using Reactome to be able to identify not just the most common associated genotoxic pathways such as DNA damage, checkpoint alterations, and disturbances in mitotic cell cycle signaling, but also to be able to look at more commonly reported, looking at the ECM organization and the cellular response to stimuli, as well as other different disease and immune system factors. The idea being here is that we can then hopefully propose new key events that we can then write about and establish back into the network, that when obviously in future studies we can then reperform these network analytics and then basically essentially begin expanding upon the initial AOP network that I developed 2 years ago.